Okay. Hi, everyone. Thank you for joining. My name is Alexandra Bogdanovic, the president of University of Belgrade SP student chapter. We have Berna Hascakir, if I pronounced it correctly, here with us today. She is the associate professor of petroleum engineering of Flowtech Industries Incorporated Career Development Professor and director of the heavy oil shales, oil sands, and carbonate analysis and recovery methods research team at Texas A&M University. And without further ado, I will let Berna take the lead. I will add that you can ask questions if you have any during the presentation. Just raise your hand, or you can ask at the end of the presentation. Just put a mark on the number of the slide you want to ask your question to. That's all, Berna.
Okay, thank you. Okay, so thanks for the opportunity. So I'm by training both environmental engineer and petroleum engineer, and I believe that right now I will discuss this topic fairly, but this is a kind of a really controversial topic. Everybody is just avoiding to talk about, and we are always trying to blame petroleum engineers. As an environmental engineer and as a petroleum engineer, let's see who to blame for the gas emissions due to oil and gas production. So I would like to just give briefly outline of my talk. First of all, what petroleum engineers responsible as gas emissions we will talk about, then gas emissions due to oil and gas consumption and impact of gas emissions on climate change, and the historical data on gas emissions, and then I will conclude my presentation. So we will start with the petroleum engineers portion contribution to gas emissions, okay? So we are in general mixing up oil and gas consumption with oil and gas production. Before I start my talk, I would like to be 100% sure that everybody knows the difference. So you are seeing right now here the voyage of petroleum. Petroleum is getting explored and then going all the way through here, and we are using petroleum in our houses. Regardless, we are petroleum engineers or non-petroleum engineers. And petroleum engineers are the ones who are producing oil and gas, and we will mainly discuss the gas emissions due to oil and gas production first, okay? And while I'm talking about oil and gas production, I'm talking about upstream, and as a petroleum engineer, I'm responsible till here. From this point on, it is the consumption of petroleum, and first we will concentrate on here, and we will not go in many details for this section because you're looking for our contribution as petroleum engineers to gas emissions. And we are, petroleum engineers are upstream guys. So we are upstream people. We are producing, exploring the oil and producing petroleum. And during this voyage, what are the contributors to gas emissions? In this voyage, while I'm doing my job as a petroleum engineer, where I am causing emissions. Let's see. First is exploration and production. The second is flaring and venting. And the third contributor is fugitive emissions during oil and gas production. So while I'm talking about those things, I want you to be aware that every gas has different impact on the environment. So carbon dioxide has different impact, methane has different impact. If I will just put down carbon dioxide impact and methane impact in a same level, then I would not really represent the problem in a big picture. So because these are apples and pears, you cannot compare apples and pears. You need to convert them in a kind of one unique unit. So instead of just mentioning carbon dioxide, methane, because their impacts are different, we need to mention something unique that we can understand and convert and normalize their impact in one unit. And this is known as global warming potential. So instead of like saying the impact of carbon dioxide or impact of methane, we will discuss their impact on global warming, and it is known as global warming potential. And this terminology is coming from EPA, Environmental Protection Agency. And what is the meaning of global warming potential? This potential is a measure of how much energy the emissions of 1 ton of a gas will absorb over a given period of time, relative to the emission of 1 ton of carbon dioxide according to EPA. So from now on, I am normalizing my data, regardless I'm maybe producing methane, but I'm converting that methane production to the impact of carbon dioxide. So why I'm doing that? Because according to EPA, its global warming potential, the carbon dioxide global warming potential is 1. However, methane is higher, nitrous oxide are higher, and chlorofluorocarbons are much more higher. And their impact is changing in years in the atmosphere, okay? So carbon dioxide is showing a kind of a regular trend, but methane impact is getting reduced in time, and the other gases as well getting reduced in time. So we will be converting from now on methane impact into carbon dioxide, and we will sum them up in terms of carbon dioxide, their impact, okay, from now on. So let's return back our gas emission sources due to oil and gas production. The first one is exploration and production, we said. And as petroleum engineers, we are doing a really very difficult job. We are producing petroleum in the middle of nowhere. There is no electricity and there is no human being nearby. Think about that. In a desert, you are trying to produce oil, you don't have electricity there. And think about you are in the Arctic, you are in the offshore. There is no electricity in those places, but you need electricity to power the facilities that you are living in as petroleum engineer. You cannot go home from here, you need to live there. So there are some facilities for you to live inside, and how you can power those facilities, there is no electricity. So how you are powering them? By what you are producing. So you are producing oil and you are burning it to generate electricity to power the facilities on site. What else? Actually, you need also electricity to power the pumps, the compressors, to power the steam generators, okay? So also for those kind of things, you are using electricity. So during exploration and production, not only because of the oil production, but by burning the oil, you have also contribution to the gas emissions. And let's see those contributions. So this number, which is around 6.5 billion metric tons, carbon dioxide is generated annually in the United States based on 2015 data. And that much of the carbon dioxide is emitted just because of exploration and production in the United States in the same year. And this contributes from the total 1.87% of the total carbon dioxide. As I mentioned you before, this carbon dioxide actually has in it methane as well, okay, other components as well. But I'm converting all the gases into carbon dioxide so I can have one meaningful number, and then I can understand the total impact better. So as I mentioned you before, this exploration and production covers the emission coming from the facility powering surface and subsurface facilities, and in general it's emitting carbon dioxide, okay? And when I'm checking during exploration and production, I'm seeing the high contribution coming from the drilling and completion, surface facility constructions, production management, and several possible leakage during exploration and production. And we are done with the exploration and production, and we also learn that the total carbon dioxide emissions, when I'm comparing the carbon dioxide emissions in the United States, it is just 1.87% of that total carbon dioxide emission. And the second one is flaring and venting. Actually, this is the most this is the portion that is taking most attention, and everybody is saying flaring is not good, don't flare it, and let's see which one is worse. So we are producing a lot of gas. If you know pressure, volume, and temperature relationship in the reservoir and in the surface, you should know that the gas that you are having in the reservoir is not occupying the same place at the surface. So because gases are expanding and in the reservoir condition they are compact, but when they come to the surface at atmospheric pressure, it's really not easy to handle that much gas at the surface, especially if you cannot find a market, immediate market, to sell that gas that you are producing. What you will do with that gas? You produce a lot of gas and your surface facilities are not sufficient enough to store them in the middle of nowhere in the oil field. And what you need to do with the excessive amount of gas, they are flaring it, okay? And they are converting it into carbon dioxide, or they are venting it, which means that without converting it into carbon dioxide, they are just, the oil companies are just venting it to the atmosphere, which contains not only carbon dioxide, but also methane. And we learned that methane has higher impact than carbon dioxide on the environmentally much more dangerous. So let's see the flaring and venting impact. So what we are seeing here, first of all, the definition of flaring and venting, as I mentioned. If there's no market, then what we need to do, we can re-inject back to the reservoir as an enhanced oil recovery fluid, because the gases that we are injecting underground as an enhanced oil recovery method are also petroleum products. But it might be really too high, too costly, okay? And we may not need that much gas to inject under the ground. And what they are doing, they are flaring it. And you are seeing here the US map, night vision, and you are seeing very highly populated cities, and you can see in the night vision they are just burning, which means that they have a lot of lights, because this is like New York, around New York area, and a lot of lights you can see. But while we are just taking closer look to this area, there is not a big city in here, so they are not electricity actually. This is due to flaring in the Bacon area. So Bacon is a shale formation, and they are flaring in this area the excessive amount of gas, and it took a lot of attention because of this image. It took a lot of attention, and they started to say, don't flare. But we should also propose a solution. If they will not flare, and if it will not be visible during night, then most probably they are venting. Do we want them to vent as well? It is worse than flaring, because the carbon dioxide is has less impact than methane to the environment. So if they will produce that much of gas, if they cannot stop, I will prefer, as an environmental engineer and as a petroleum engineer, I will prefer them to flare it rather than venting it. And let's check the total impact due to flaring and venting. So during flaring and venting in 2015, United States emitted 84 million metric ton of carbon dioxide to the atmosphere, and it is it corresponds to 1.28% of the total carbon dioxide emissions in the United States. Okay. We are done with this too, and I'm writing down their impact when we are checking the US carbon dioxide emissions, and now we are with the fugitive emissions. And during exploration of production, we petroleum engineers are using a lot of pipes to transport the produced oil and gas from one location to another location. And we are thinking that we can have perfect pipes. There is not such a thing, perfect pipe, okay? In every case, we have leaks all the time, and fugitive emissions are due to those leaks. You can make it better and better. You can reduce the fugitive emissions as much as possible, but it is nearly impossible to make them zero, okay? And we have a lot of fugitive emissions, and they are unexpected. They are not intentionally, okay, done. And there might be also some accidental emissions because of the blowouts, because of the leakage through the well, or because maybe you injected a lot of fluid under the ground and you caused a break to the caprock, and then from the caprock the fractures caused some leakage through the geologic formation as well. And this is also dangerous like venting because it emits methane. Methane is dangerous, much more dangerous than carbon dioxide. And when we are checking the total impact of fugitive emissions for 2015, what we are seeing, 30 million metric tons of carbon dioxide has been released due to fugitive emissions in 2015, and its contribution to total carbon dioxide emission is 0.45%. Okay, so we learn each portion due to oil and gas production. Now let's sum them up to see what is the contribution of oil and gas production to gas emissions in the United States. It is 3.6% annually. Okay, and I'm converting methane also into carbon dioxide, and this number is in terms of carbon dioxide. And the other sources then 3.6% is coming due to oil and gas production, and the rest is coming from where? The rest is coming from the electricity and heat production, building, transportation, and other industry. And the 3.6 is here, right here in the other energy portion, okay, according to EPA classification. Okay, so this is the contribution of oil and gas industry, oil and gas production. And when we are just checking the contribution of each item, we are seeing the main contributors exploration and production, and then the second is coming flaring and venting, and the third one is fugitive emissions. Okay, we are done with the emissions due to oil and gas production. Now we will review the emissions due to oil and gas consumption. Okay, so for the oil and gas consumption, what we need to know that who to blame first. Okay, who is consuming more the oil and gas? So who is consuming more? For sure, United States is #1 as a consumer, and the European Union countries are #2. So you are in Europe, and I'm in United States right now. So who to blame? Both of us, okay? And then China is coming in the third place. And who to blame? Should we blame China, or we are using made in China products a lot? So everybody, we need to actually blame everybody about this consumption. Okay, so the world consumption is really increasing a lot, and this contribution to carbon dioxide emissions will increase in the future as well. Maybe we put a pause this year on oil consumption because of the pandemic, but the next years we will just continue to consume more and more oil and gas. And then the question is, I'm using it for what reason? Actually, we are using it for the energy generation. And when we are just checking the other energy resources that I can just generate energy, renewable energies, nuclear energy, apart from the fossil fuels, coal, gas, and oil, which are causing a lot of carbon, which are resulted in carbon footprints. Their development is ramp up, and I hope in the future we will see more energy generation from the renewables and nuclear sources as well. As a petroleum engineer, I'm not saying that we should rely on only oil, because we are growing in population. In the future, we will need more and more energy, and it is always good to do research on different energy sources and reliable energy sources that we can rely in, not infinite energy sources, not finite energy sources, but infinite energy sources like renewable energy. That's why I'm in favor of renewable, and I'm in favor of nuclear as well, because we will need in the future all of them. Okay. And the electricity source, when we are just checking the fossil fuels, I would like to understand more about as a petroleum engineer, how much of the gas that I'm producing is getting converted into electricity. So you are seeing here the electricity generation based on different sources in the United States, and renewables are 15%. We have liquid petroleum here and gas petroleum here, and the coal here, and the nuclear sources here. Okay, so the electricity generation is 35% of the gas is getting consumed for electricity generation, and the rest is mainly getting consumed by heating purposes. And we are consuming electricity where? Actually, we are consuming electricity in our daily life for domestic appliance uses. And because electricity is coming from carbon source, coming from a fossil fuel, then we have also carbon dioxide emissions when we are turning on the lights in our houses. We are using a computer when we are cooking, when we are cleaning the house, and while I'm giving this talk as well, and while you are listening me, because you are consuming also electricity. And what we are seeing, because our lives are getting more and more and more comfortable with the use of these domestic appliances, the carbon dioxide footprint due to the use of those appliances are getting increased, because we are consuming electricity and we are highly dependent on our comfortable lives. And the other thing, the electricity, I would like to take your attention is the automotive case. And here I'm just comparing the electric car with luxury cars that they are using petroleum, and a small car which is using again petroleum. And I'm trying to compare their carbon dioxide emissions per kilometer and fuel consumption per 100 kilometer. And I'm also comparing the flights. So if you're taking flights, or if you are taking a kind of public transportation, you still have carbon footprint because of the fuel consumption. But we would like to know also, if I'm using an electric car, do I have still a carbon footprint or not? Okay. When I'm checking this, what I'm seeing for United States case as the carbon footprint of an electric car is this much. Okay, so it is more than a small car. And this small car that most of the European countries are using small cars, and this is a little bit bigger than those small cars that we made in here. And you are seeing this is contributing also to carbon dioxide emissions, but this is an electric car. So how come it can contribute to carbon dioxide emissions? Because the electricity is coming from the fossil fuel, and it is getting centralized in the United States and getting distributed from the center. And we need to be aware that this electricity has a carbon footprint as well. Okay. And what else? Where else I'm using petroleum? I'm using it for transportation, as we discussed through the automotive case, and this is causing some pollution. And also, we are using it for the petrochemical industry. Okay, gas, even for the gas petroleum, I have a small portion that I'm converting it to petrochemicals, and for the liquid petroleum, I'm using more for petrochemicals. And those petrochemicals are the chemicals that we are using in our daily lives. The soap that we are cleaning our hands to protect ourselves from coronavirus is a petroleum product. And also the roads are petroleum product. The car itself is a petroleum product, most of the parts in the car. And my mouse is a petroleum product, my keyboard, my camera. So because of petroleum, you can see me. The cables are made from petroleum, right? And the clothes are made from petroleum. Many clothes are made from petroleum. So not only the petroleum production, but the petroleum conversion into a transportation liquid into petrochemical products are causing also gas emissions. And this is a refinery picture, okay? And the refinery, we are converting petroleum into usable daily life products, and we have many footprints of the refineries as well. Okay, so we reviewed also gas consumption. Oil and gas consumption is causing gas emissions, a significant amount of gas emissions. Let's check impact of gas emissions. This gas emissions due to fossil fuel production and consumption on climate change. So first of all, we need to understand what is climate. There's another misconception that we are mixing up climate with weather. So we are seeing today is sunny and tomorrow is suddenly the temperature is dropping, and we are thinking about that the climate change. No, it is just weather, okay? While we're talking about climate and weather, we should understand that climate is a long time frame effect and the weather is short time frame effect, okay? It can be local or global. And we shouldn't mix up climate change with the global warming, and the global warming is just a consequence of the climate change. And the global warming means that on average temperature increase at the Earth's surface and in the ocean, but locally warming or cooling can be observed. Let's say here I'm having like hot summers, but let's say in other areas can have really cold summer, okay? And they may think that they were talking about global warming, but we are having a colder winter, okay, colder summer here. But I'm having here hot summer and hot winter. When you check the average temperature of the Earth, it's increasing, but locally your temperature might be decreasing because my temperature is increasing extremely. That's why the overall impact is showing me that globally I'm observing a warming, okay? And this is actually scientifically proven as well that the Earth temperature is steadily increasing, and this steady increase is overlapping with the carbon dioxide emissions. And here is the Earth picture taken by NASA in time, and what you are seeing that the Earth is getting red and red, more red, which means that the surface of the Earth is getting, the temperature of the Earth is getting increased in years. So global warming is real. So I would like to remind you again that the global warming potential, and we are always taking the base case carbon dioxide and we are normalizing all of the gases to carbon dioxide. But I would like to know more about the factors affecting the global warming and greenhouse gases. The main influencing factor is anthropogenic factor. It's because of me, because of my consumption to carbon resources, to fossil fuel resources. I am consuming fossil fuel and I'm causing an increase in the Earth temperature. And the consequence is not increasing in Earth temperature, but ice sheet volume change and then the temperature of the Earth is changing, and the sea level also is changing in Earth. And the concern is like the temperature will increase 1 to 6 degrees on Earth, and which means that this is an average number by 2100, and the sea level will increase in some areas 0.4 meters to 3 meters. Okay, and the main reason is greenhouse gas emissions, and we have already reviewed those greenhouse gases in terms of global warming potential. Okay, so I would like to go into detail about the greenhouse gases, and there's a misconception about the greenhouse gases, and we are saying that we need to blame water because the main greenhouse gas is water. It is true, the main greenhouse gas is water vapor, and as you can see, it is keeping the sunlight to go back, but it's not the only gas. We have high amount of carbon dioxide, we have methane, and the other sources as well, greenhouses. While the greatest contributor is water, because its impact is not changing in time. However, carbon dioxide is changing, methane is changing, so we shouldn't concentrate on the water, but we should be concentrating on these components, and we should redraw our pie chart by excluding water. But we will keep in our mind that water is also greenhouse gas. And as you can see, the main contributor is carbon dioxide coming from the fossil fuel. However, carbon dioxide is also coming from the forestry and land use, okay? Not only fossil fuel production and consumption, but also the forestry as well. And we also already reviewed that methane is much more dangerous than carbon dioxide. And the other gases, we are not focusing here because in petroleum production, we are not seeing those gases emitted to the atmosphere. So we are done with the impact of gas emissions on climate change as well. So I would like to go into detail the historic data on gas emissions, because I'm hearing a lot of misconception on that as well. So what I'm hearing that carbon dioxide is changing always in geologic time, and it's true. It always changed a lot. The carbon dioxide levels of Earth has been changing a lot, and it has happening in million years like that. And this is the current time, okay, 0, and this is the geologic time. And while I'm just checking this, I'm seeing a big error range as well, okay? And as you can imagine, this data shouldn't be that much easy to collect. And this is the ratio between current and the previous atmospheric conditions, okay? Current means 1997 carbon dioxide concentration. And while I'm checking here, I would like to know how fast the carbon dioxide was changing. I'm seeing that it was changing, but the scale is too big. It's million years, okay? I would like to see how fast it was changing. And what I'm seeing, this is the fastest change that I'm seeing as a slope here. And even in the error range, I'm seeing that slope. The fastest change is 0.007 ppm per 50 years. In geologic time, this was the fastest carbon dioxide change in the atmosphere. And let's check current situation. In the current situation, this scale is years. This is million years and this is years. And right now it is 80 ppm per 50 years. It has been changed a lot, as you can see, okay? So from 0.007 to 80 ppm. Here, there were a lot of living organisms. They could adapt their lungs to this change, but can we adapt our lungs to this change? It will change a lot as well, okay, in the coming years. Are we ready? Our lungs are ready to this change. This is the question that we need to ask ourselves. Now I would like to conclude my talk after I reviewed all of the misconceptions. I hope you didn't have those misconceptions, but if you had those misconceptions as well, you cleared them out. And here in the conclusion, what we said, oil and gas production responsible in the United States around 3.6% of the greenhouse gas emissions, and the similar ratio can be also reasonably accepted worldwide. And when we come, what we can do actually, how we can reduce our footprints more by just trying to mitigate the greenhouse gas emissions and the consequences. How we can do that by reducing the oil and gas production and consumption. Are we ready? Are the technologies ready? Can we produce my clothes from sun? Okay, so we are really highly dependent on carbon inside the oil, not as an energy source only, but also as a carbon source. We need this product, and we need to diversify energy, which means that we shouldn't oppose to renewable energy. We shouldn't oppose to nuclear energy, as long as we are doing our engineering calculations properly. We can do everything safer. Even the nuclear can be safe and much more beneficial. And if we would continue with oil and gas, and we will continue with oil and gas, we will not sacrifice our comfortable lives, and we means not only petroleum engineers, but everybody. Now, how we can mitigate its emissions? We can do more carbon dioxide sequestration projects. And this is also part of petroleum engineers' job. Petroleum engineers are using carbon dioxide as an enhanced oil recovery fluid, and they can inject to recover more oil, and for the sequestration of carbon dioxide as well. Petroleum engineers are the experts on the underground storage, because we know underground more and the best when comparing the other engineering disciplines. And we can use less catalytic converter, which will produce more pollution, and we can do some research on really crazy ideas about cooling the world. That something like space umbrella, thin particles in the upper atmosphere, it can be also considered to mitigate the emissions effect. So this is all about my talk, and I would like to thank to my Master of Engineering student in the preparation of this presentation. Oliver is right now a reservoir engineer in Total in France, and if you have any question, I'm glad to answer and address all of them. Thank you for your attention.
Thank you for your presentations.
Sure.
Do we have a question from audience? In meantime, I do have a question.
Sure.
So there are companies, US companies with a net zero policy. And what are the consequences for US considering that they escaped the Paris Agreement?
Okay, so this is a little bit like politics, right? So we are escaping all the time to answer those kind of things. Our president has been changed. I believe their new policy will be different than the previous one. And what Biden is saying, President Biden, I believe we will take our precautions for the climate change in the United States. I believe for the zero emissions, it's a kind of a very optimistic, to be honest with you. I hope everybody can achieve it. But it is just a goal, okay? So we hope it would happen, but I'm not that much optimistic for the zero emissions, because we are consuming a lot. All of us are consuming a lot.
Thank you.
Sure.
I was doing a research paper, and one of my topics was EPA. So I wanted to ask you, is EPA dealing with emissions?
Sure. Environmental Protection Agency is dealing with both the emissions and the, so you can find a lot of information on EPA website. So most of the information that we got here from Environmental Protection Agency website. You can use it, but don't forget that in the United States, every state has their own regulations as well. And the state-by-state regulations can change. They can take EPA's recommendations, but they may not as well. In Texas and in the West Coast and the East Coast, the situation is different. So it is a state decision mostly, not the federal government decision in the United States.
Right, thank you. I don't know if anyone has a question, they can ask it now. We would like to hear some of you.
Okay, hello everyone. I have one question. Firstly, Berna, thank you for your presentation. It was really nice. And my question is related to the fugitive emissions. How do you measure it? Is it possible to measure fugitive emissions?
So that's a perfect question. Okay, as engineers, okay, we are all engineers, I hope, in here.
Yeah.
So as engineers, we need to do our mass balance all the time. Okay, so while you are just determining a reserve in the reservoir and at the surface, so you know your mass, and while this mass is traveling through the pipes, at the end you are getting another mass. If there is a difference between and in the production point and in the transfer point, a difference in the mass of that produced gas or produced oil, then the rest means that escaped through the lakes. Okay, so this is through the mass flow meters we are doing it. If it is not visible like that. So let's say you are producing 1 million stop tank barrel of oil, and then you are just ending up not 1 million, but let's say 999, and then the missing is just because of the vegetative. Okay, I hope it is answering your question. Through the mass balance we are understanding.
Yeah, sure. But also, for example, how you can measure the inlet into the process, for example. Sometimes it is not so accurate.
So most of the times, most probably, it's not that much accurate.
Yeah.
But this is the money source. Okay, at the wellhead, especially what I'm saying, I'm teaching those kind of classes as well. I design classes, how we can design from the reservoir to the surface, how we can make our designs possible. And while I'm lecturing them, we are measuring everything everywhere. Okay, and in general we are measuring in volumes, and then we are converting those volumes into masses to be on the safe side, because there's not a volume balance. So in theory, in lecturing, as petroleum engineers, as any engineers, we need to do always our mass balance calculations. We need to always know how much we are producing in each step. So we have a lot of meters, like gas meters, and from the pressure and volume changes, you can easily understand from wellhead to other place how the mass is changing. You can, as long as you know the volume and the pressure at different two locations, you can apply different equations like Bernoulli, let's say, and then you can calculate how mass is changing from one location to another. In general, what we know that how much oil we will produce and how much oil we are producing in the wellhead. And that oil that we are producing, or the gas that we are producing, if it is not ended up the same mass while it is traveling to the end, then the difference is fugitive, for sure.
Yeah, but for example, if you have a multi-phase inflow, you have oil and gas in the same time on the wellhead, and for your calculation, you need actually the composition for that
Yes.
fluid. Yeah. And,
yes.
Yeah, and how do you, for example, how to say that?
So if you don't have the composition data,
Yeah.
how you are calculating? Okay, this is the class that I'm teaching. It is called reservoir fluids, and the code is 310 here. And Dr. McCain, who recently passed away, has a book on petroleum properties. So in this book, you can see that if you have full data about what you are producing, you can do really precise calculations. And if you know your reservoir is a volatile oil, black oil, wet gas, dry gas, whatever, 5 different types of reservoirs, and then you can do all of your calculation based on what is written in that book. And in that book also there's another chapter. It is saying that if you don't have that information, let's say you don't know the composition, you don't know a lot of things about the reservoir, what you will do based on the experiences, what they have formed a lot of charts for those kind of reservoirs. And for those kind of reservoirs, you're using pressure data to estimate the solution gas in place, RS in place, and you're reading from those graphs what kind of, how much gas you have before reaching the bubble point and after bubble point. And these are presented with the charts, and those charts are reliable because they have been formed by using like around 500 or more than 500 reservoir information. And but if you're talking about unconventionals, we are dealing right now in the United States a lot. It's a big question. It's a very big question right now with the unconventional. Those charts are not available for unconventional, so we need to be very careful while we are dealing with the unconventional. It will be very difficult to find that fugitive emissions for the unconventional reservoirs. You're right. But the conventional reservoir, we have that information. You can find it from Dr. McCain's book. If you have the data, if you don't have the data, you can easily find that information by using charts. Okay?
Okay, thank you for your answer.
Sure, no problem.
Anyone else?
Well, I guess this means we don't have any questions, right? Yeah, okay. Thank you, Berna. This was a great presentation.
Thank you so much.
It was a pleasure.
Sure, thanks a lot for the opportunity as well. Okay.
Yes, I hope you're satisfied.
Yes, I will be happier if I will get more questions. Like the last one, I enjoyed a lot to answer that question. And I can give also PVT related lecture later if you want.
Well, our students are a bit shy, so.
As an instructor, what I would tell you, if you are getting questions, it means that audience enjoyed topic a lot. So I would prefer to get more and more questions. Okay, and for the shy students, what I can say, these are really good platforms to interact with different people. And so it is good to know a person, but it is better if a lot of people know you. Okay. So in order to be recognized, in order to be known by different people, you need to speak out more and more. And what I'm seeing from Alexandra, she has a really good self-confidence. I hope that everybody can build a similar self-confidence because you can be better in the future while you're interacting with different people. Okay. Thanks a lot again, Alexandra, for the opportunity.
Thank you very much. It was a pleasure.
I enjoyed it as well. Sure. Okay.
Thank you.
I will send you.
I will send you the link when it is ready.
Okay. Thank you so much. Okay.
Okay. Bye.
Bye, guys.